Half a day students, for today's video we're going to be going into a new topic which is all about rational expressions. For this video we're going to be concentrating on simplifying rational expressions with monomials and then ones with polynomials. First off, a rational expression is an expression of the form p over q, when p and q are both polynomials. And keep in mind that polynomials with one term, are still considered polynomials. And we also need to make sure that our q, our denominator, is not 0. Essentially, it's just a fraction. So an example of a rational expression is x squared minus 9 divided by x squared plus 5x plus 6. Here we have a binomial divided by a trinomial. And this whole thing is considered a rational expression. We're going to go straight into simplifying monomial rational expressions. So for these ones, you'll divide the numerator and the denominator by their greatest common factor. And to do this, prime factorization could come in handy if you want to use it. So I'll show you some ways to use it, but just keep in mind you can just simplify as you know how to simplify. You don't always have to write out all the factors. For example, 9 over 12, I'll show you the prime factorization, but this is fairly easy, so we can do it without it, but let me just do it to show. So 9 over 12, I know it's just going to be 3 times 3 divided by 3 times 4, right? The reason that we show the prime factorization is because 1 3 on the top will cancel out 1 at the bottom, and your simplification is going to be 3 over 4. But I can do this just by dividing by, okay, I know that 9 and 12 are both divisible by 3. I can just jump straight to 3 over 4. For this one at the bottom, a way to do it using prime factorization would be to find the prime factorization of each. 8 I know is just 2 times 4, and then I have 2a's divided by 14a to the 5th. I know that's 2 times 7. I have 5 of. So this is very similar to what we did in the first topic, but we're just going to be adding on to this. So 1, 2 is canceled, and then 2a's are canceled. And I'm left with 4 over 7a to the 3rd power. An alternative way to do this, I'll do this in green on the bottom. We have 8a squared over 14a to the 5th. I might just say, okay, 8 and 14, I can divide each of these by 2, so I'll get 4 and 7. A squared, I know is going to be gone, the smaller one's gone. This 5, I'll just subtract 2 from the 5. Canceled out 2, and I'm left with the same answer, 4 over 7a cubed. So if you could do it this way on the bottom, that's perfect. If you can find use in doing prime factorization, go for it. This next one, we have a bunch of different terms, so let me actually just rewrite it so it's bigger. 16x to the 5th y cubed over 14x squared y to the 10th power. From here, 16 and 4, I know they're both divisible by 2. Oops, sorry. This is going to be 8, and this one's 7. X to the 5th and x squared. I know x squared is smaller, so it's going to be canceled out. This 5th power is going to change to a 3rd power because I'm going to do 5 minus 2. For the y's, the smaller one exponent is going to be out. This exponent is going to change to 10 minus 3, which is 7. And I'm left with, now, in my numerator I have 8, and I have an x cubed. In the denominator, I have 7y to the 10th power. And you always want to look at your answer again to see if there's anything else you can do to simplify it. In this case, it's already in its simplest form, so I'll leave it there. Now we're going to look into simplifying polynomial rational expressions. For this, there's 2 steps. First step is to simplify, or first step is to factor, Second step is to simplify. So looking at this first example, 5x plus 10 divided by x plus 2. So whenever you're doing this, you want to simplify the simpler side first, right? So my denominator here is simpler, but I can't factor anything out. So I'll factor something out of the first one, the numerator. So if I had 5x plus 10 over x plus 2, I know 5x plus 10, I can factor out 5, right? I'm left with x plus 2, and the new denominator will stay the same. When we're simplifying rational expressions, we're basically trying to break them up, break them down, and then see what I can cancel out. And you'll notice that while you're factoring, hey, I have an x plus 2 on the top and an x plus 2 on the bottom. Since it's multiplied, I can actually just cancel this out. And this comes out to just be 5. And this is why it's a good step to simplify the easier side first, because it'll give you a hint to what the factorization might be in the other side of the equation, or other side of the division line. For this example, I'll rewrite it so it's bigger. So we have 4x minus 8 divided by 2 minus x. Okay, my numerator is easy to factor. They're both divisible by 4. I'm left with x minus 2. My denominator, it looks weird to me, right? Remember in the last video where we talked about things kind of being backwards? It's kind of a trick question. So for this one, I might want to actually write it as negative x plus 2. So I just switched places with them, kept their signs the same. Okay, but now it's looking a little bit better, but I cannot cancel yet because negative x plus 2 is not the same as x minus 2. What I'm going to do is I'm going to force my denominator to match this x minus 2 by factoring out negative 1. Because when you factor negative 1, it'll change the sign of each of these, right? So we have in our numerator is going to be the same. My denominator, on the other hand, after factoring out negative 1, I'm left with positive x minus 2. And see, from there, now I can cancel because it's the same thing. I'm left with 4 divided by negative 1. Simplifying that will give me negative 4. So be careful with ones like this. You always want to switch it to where it looks kind of normal. Okay, looking at this one, x squared minus 9 divided by x squared plus 5x plus 6. We always want to work on the easier side first, and the easier side for this one is actually going to be my numerator, right? So I'll use the difference of squares. I know the factorization of x squared minus 9 is just x plus 3 times x minus 3. For this denominator, I'll factor it on the side just to save space. Okay, so we have plus, I'm looking for a sum, right? And they're going to have the same sign. The ones I have to choose from are x, and 2, 3, and 1, 6. So I'm pretty sure I'll use 2, 3 because both of these had 3, right? So I'm going to use my answers from the easier side to inform my guesses from the more difficult side. So I can say, okay, maybe it's x plus 2 times x plus 3. Checking this, 3x plus 2x is 5x. So this is actually the correct factorization. So we have x plus 2 times x plus 3. I'm able to cancel now. What do you have in common? X plus 3 and x plus 3. My answer comes out to x minus 3 divided by x plus 2. If you want to keep the parentheses there, you can, but it's not necessary. Factor each side, cancel out what you can. Moving on to our last example, we have more than one variable, so be careful with this. Looking at this, my denominator only has 2 terms, right? So that one's going to be a lot easier to factor. 2x squared plus xy minus 6y squared over 2x squared y plus 4x y squared. Here, looking at my denominator, I'm going to factor them out. They both have at least 2 and at least 1x and at least 1y. And then I'm left with an x in the first term, and in the second term I'm left with 2y. So this is going to inform my factorization of the top. So let me factor the top on the right side. So with green, we have 2x squared plus xy minus 6y squared. Factors of 2x squared are 2x and x. Factors of 6y squared are 2y, 3y, and then y and 6y. So which one do we think we might use? Which pair? I'm thinking x plus 2y is probably a pair, right? And they're going to have different signs, and I'm looking for a difference. So I'm going to use whatever will give me x plus 2y. Sorry. Choose this one. So we have x plus 2y. And since they're different signs, the other one's going to be negative. I'm going to use whatever's left. So I'm left with 2x minus 3y. I'll check these to see if it's correct. We have negative 3xy. Then I have 4xy. Combining these, I'm left with 1xy. Since it's the same as my middle term, this is the correct factorization. So we have x plus 2y times 2x minus 3y. So since this numerator actually would have been a lot harder to factor, right? I could have done a lot of guesses, but since I did the easy side first, I was able to say, okay, this is probably one of the factors of my numerator. So that's how I was able to get this x plus 2y and then figure out the other side very easily. So that's a good hint to do. It's a good way to do it, is to do the easier side first. Use that to inform your guesses in the next one, because like we said, factoring is really just a bunch of guessing. Once we're simplifying, just factor or cancel out whatever we have in both, and then just write whatever's left. 2x minus 3y divided by 2xy. And then that's it. That's it for the examples. You might benefit from doing a lot of practice for this one, so I suggest you do the odd numbers in the book and then check the back to see if your answers are correct.